Hi class, let's take a look at this example. And notice that this example, technically it's part of the formula ones, so this could be considered technically a proof. But the instructions on the problems are to actually use by parts. So the most appropriate portion to use here is you let u equal to technically the ln of x, and technically the actual values of dv is equal to dx, and this will give us a du equal to 1 over x dx, and technically the v is equal to your x value. So as we rewrite this integral, we're still looking at the general form of uv minus the integral of v du, and see if this actually reduces in some form. So your u, actually u and v, it's just going to be x ln x minus the integral of v, in this case x, and then du happens to be 1 over x dx. So we're looking at x ln of x minus the integral of dx, since your actual x's cancel out. So we're looking at evaluating just an x ln of x minus technically x plus the constant of integration. So that would be our final answer, which happens to be the general formula of the integral of ln of x.